Hi there, we are the Vacuum Cannon Group and today we're gonna learn about how to build a vacuum cannon. The materials we'll need to build the vacuum cannon are a 2 meter 50 mm diameter PVC pipe, a 2 meter 32 mm diameter PVC pipe, two 40 mm PVC caps, and... Wait, what? You really thought we were going to watch another boring tutorial? Well, of course not. Hold tight and prepare for the best tutorial you've ever seen. The materials we'll need to build the vacuum cannon are a 2 meter 50 mm diameter PVC pipe and a 2 meter 32 mm diameter PVC pipe, two 40 mm PVC caps, some 40 mm rubber bands, a 5 meter thin and resistant rope, small plastic cups that fit inside the 50 mm tube and 42 mm interior, and finally some ping pong balls to shoot out of the cannon. Now that we've seen all the materials we'll need, I'll tell you about the tools. Special glue for PVC, a hot glue gun, a 3D printer to print some of the parts we needed, a drill to make holes in the PVC, some soap or something slippery, PVC scissors, and some sandpaper.
Oof, that was a long list. Now, let's start with the construction of the vacuum cannon. We'll split the steps into two main parts: assembling the piston that will go inside the cannon and create the vacuum, and preparing the tube to be used. First, we'll start with the piston. Take the 32 mm tube and one PVC cap and fit it in one end of the tube. With a pencil, mark where it reaches and take the cap out. Once you've done that, take the measure and double it on the other side, leaving enough space for a rubber band to fit in between the caps. Once measured that, cut the PVC tube with the PVC scissors. Fit both caps in either side of the PVC tube and ensure you've left enough space to fit the rubber band in between the caps. Important! Don't throw away the remaining tube, we'll need it for later when we use the cannon. Next step is to take the drill and make two small holes in one of the caps, just big enough so you can pass the 5-meter rope inside of them. Make a tight knot and secure the rope to the cap. You can use hot glue to further fix the knot, but you can make it work without it. Just make sure the rope doesn't obstruct the path of the PVC tube if you've taken out the cap to drill the holes in it. Third step is to 3D print a ring that fits in the space you've left. The purpose of this ring is to raise the rubber band enough so that it'll make contact with the inside of the 50 mm tube. We used some 36.5 mm rings, but you'll probably have to test for different sizes until you find the perfect one. Once you've done that, fit the ring around the PVC pipe and in between both caps and slide the rubber band in until it gets in the gap formed by the 3D printed ring. Check if it fits inside of the 50 mm pipe, and if it, with not a lot of effort, it slides into the pipe. It is important to have in mind that the piston will be looped when used, so don't worry if it's a bit hard to push. If it fits and feels airtight, you can now glue on all the parts with the special PVC glue. Start by gluing the cap with the rope tied to it to the 32 mm PVC pipe. Next, add the 3D printed ring and also glue it. Make sure to respect the drying time of the glue before gluing the next piece in. Continue by gluing the second cap on the other side of the pipe. Finally, slide the rubber band over the PVC caps and glue it in. Congratulations! You've built an airtight piston! Now that the piston is done and dusted, we'll move on to prepare the 50 mm PVC pipe for its use. First of all, we'll sand out both ends of the tube, removing all sharp edges and ensuring it is smooth. This step is important to avoid air leaking through small imperfections of the PVC tube. Finally, we'll wash the inside of the tube with a bit of water and soap and let it completely dry off. And that's it! You have all the pieces to use your new vacuum cannon.
Now, let's move on to the explanation of how to make it work. First of all, we'll leave the piston by applying some soap onto its surface, then facing the rubber band, which will be the part that directly touches the inside of the electrode. Once loved, take the piston and with the help of the remaining part of the 32 mm tube, we'll insert the piston into the 50mm tube and push it with the 32mm pipe until it reaches the other side. Alternatively, you can drop the rope along the pipe, but it's better to use this method so you loop the whole tube with the pass of the red loop piston. Once you have done that, fit a ping pong ball in between the end of the tube and the pistons. Place a plastic cap button first on top of the ball. Press it until its sides touches the top. Don't press it too hard into the tube, as it can damage the cap before it's used. Just let the vacuum do the job. Finally, have one you holding the job and the other one grab the rope. Point it somewhere safe and far away of anyone. Have in mind that only dangerous points are in front of the cannon and a few meters behind, as when the piston gets pulled out, it goes fast and can collide with someone if you are too close. So it's important to only have 2 people operating the cannon and the rest far away or at the sides of the cannon where there is no risk at all. Now it's the moment of truth. Take the rope and pull as hard and as fast as you can backwards. If you have done it correctly, you should end up with something like this.
So, how does this work? In this relatively small device, 10 of physics laws work together to launch a projectile at a theoretical maximum speed of the sound, though we have not managed to launch it as fast yet. First of all, we have a long PVC pipe. The longer the pipe is, the harder it is to shoot, but the faster the projectile will go. Then we have to somehow block one side of the pipe to make a vacuum. After what felt like months of hundreds of tests, and with tens of membranes, we settled on a simple plastic cup. This is the perfect membrane, because it's a good enough seal that it won't let any air come out, and at the same time it will just pop out when the projectile has to exit from the other side. We've also built a small piston attached to a string that's airtight, and we're using a ping pong ball as a projectile. When we've constructed all the pieces, we push the piston inside the pipe and place the ball on top of the piston. Then we place the cup on one side of the pipe and push softly on it. So how do all the physics of this work? Now there's a small area at the pipe that's airtight between the pipe and the plastic cup, and in that space we've placed the projectile. The only thing that's left to do is to pull the string with the piston, and when the piston slides back, the small quantity of air that's trapped will expand to the whole length of the pipe. A vacuum will be created in that space, because there will be a lot more space for the same amount of air, so the pressure will drastically drop. Then we will pull out the piston. The air will rapidly enter the pipe caused by the difference in pressure, and it will push and accelerate the projectile. Finally, when the projectile gets closer to the end of the pipe, it will have compressed the air it had in front of it, to the point where the pressure will be higher than outside, and that will push the plastic cup out, letting the ball escape without losing any energy.
As you have probably seen, there are some things still to improve and perfect. First of all, the ping pong ball is 2 mm smaller than the interior of the tube, so there is a bit of air going around the ball and not pushing it perfectly. So as an improvement for the cannon, printing a ball that exactly fits the tube will help a lot to improve the speed and efficiency of the cannon. Second, we are yet to find a better way to pull the string. We tried making and using a crank without success, as the rope has to pull fast and with a lot of force in order to preserve the best below pressure. The last unsolved problem we have is that cannon break a cap each time if you shoot it, so it's very wasteful. We have not yet figured out another working membrane despite trying dozens of membranes without any success. So that's a problem we leave to the future people that build this vacuum cannon. We'd love to hear from someone that has figured out a way. Well, that's all for today. Hope this video has been useful. Now you can build a vacuum cannon by your own. Please leave a like and subscribe if you have liked the video. Just kidding. Hope you have enjoyed and see you next time.
Bye!